and a very warm welcome to the IEEE Extreme 18.0 online workshop series day 1. Thank you all for taking the time to join us with this evening. My name is Tarushi and I'll be your host for today's session. For those who are new to IEEE Extreme, it's an exciting global 24-hour programming competition organized annually by the IEEE organization. Students from around the world form teams to compete in challenging coding problems together. It's a unique opportunity to team up with your friends, improve your problem solving abilities, and enjoy the excitement of coding in real time under pressure. We also have another exciting coding event coming up, a mini hackathon called Byte Blitz, and we hope you will participate in that as well. This workshop series will be a great way to prepare for both IEEE Extreme and Byte Blitz, helping you improve your skills and get ready for these coding challenges. We have an exciting and informative session lined up for the next hour. So let's make the most of it. Before we begin, I kindly request everyone to keep your microphones muted to avoid any disruptions. If you have any questions during the session, we'll address them during the Q&A session towards the end of today's workshop. To officially begin today's session, I'd like to invite Mr. Mani Jalba, the project advisor of the Extreme 18.2, to share a few words of welcome. Over to you, Mani.
Thank you, Tarushi. So, good evening, everyone. As the advisor to the organizing committee for IEEE Extreme 18.0, it's my pleasure to welcome you to this online workshop on prompt engineering for competitive programming. So, over the years, I had the privilege of being deeply involved with IEEE Extreme, and I can confidently say that the skills you're about to learn are more relevant than ever, not just for this competition, but for your broader success in technology and problem solving. So for the past few years, computer programming has evolved dramatically, yet some fundamentals remain unchanged, such as quick thinking, efficient problem solving, and adaptability. So that's why this year we are focusing on generative AI, a tool that truly make a difference in how you approach challenges. So in Extreme, where every second counts, mastering prompt engineering can be a real game changer. From my experience overseeing the previous competitions, I've seen how participants struggle with time and energy management during the 24-hour challenge. So this new skill could be just what gives you the new edge. So I encourage all of you to fully engage with today's workshop and don't hesitate to ask questions and reach out to our guest speaker, Mr. Gihan, if you need any clarifications. And remember, the skills that you learned today, not just for IEEE Extreme, and they are invaluable for your future technologies and innovation. So thank you for being here, and I look forward for your brilliant solutions in IEEE Extreme 18.0. Thank you.
Thank you, Mr. Mani, for that warm welcome. Now it's my pleasure to introduce our speaker for today's session, today's workshop, Mr. Gihan Liyanage. He is an associate machine learning lead at Ascente Private Limited, where he's an expert in full stack development, machine learning, deep learning, natural language processing, generative AI, and large language models. He leads the data science team at Ascente, focusing on projects that use data and technology effectively. Gihan is a skilled professional and a team player who enjoys working with others. We are happy to have Mr. Gihan here to share his insights on prompt engineering for competitive programming. Sir, we kindly invite you to begin the session.
Thanks, Tarashi. Hey guys, let me share my screen. Right. Tarashi, can you make me a host if possible? I can't share the screen. Manit? Cool, thanks. So, right, let me Give me a second, guys. All right, here we go. Can you guys see the screen? Yep.
Yes, I can see.
Cool. Right. Good evening, people. Yeah, welcome to the first session for this IEEE hackathon. So the session is all about prompt engineering, basically how we can effectively communicate with the LLMs, right? So let's jump into the content. Okay, I hope, I mean, most of you guys have talked with ChatGPT, right? Um, so first thing we need to understand is, before we, talking about how we can use prompt engineering for competitive programming, is what is prompting and what is prompt engineering, right? So I hope most of you guys have an idea about, like, at least a rough idea about what is an LLM is. So LLM is basically, you can call it a probability distribution of words, right? So these are huge neural networks trained on trillions of data, text data. So what they can do is basically, when we give a text or a sentence or anything, right? It can analyze the entire, what do you call it, language or multiple languages and predict the next word, most probable word or multiple words. So that's all these LLMs are doing, right? So it just predict the next word. But then the question is how these LLMs they have become so powerful. The thing is, data, number one, and the architecture, right? I hope you all have an idea about the transform architecture, attention mechanisms, and everything. Other than this architecture, I mean, they have been trained on like huge amount of data. So the data has given the power to these LLMs. So the so there are different ways that we can interact or use LLMs. So the most simple thing is um, prompting. So what do you mean by prompting is you can just pass an input text to the LLM, so that LLM will generate an output for you, right? So the input text is called prompt, and so we have large language model, and the output generated by the LLM is called completion. So when it comes to talking to LLM, so you have three components: prompt, basically the input, and you have LLM, and you have completion, which is the output. Usually the output, the completion consists of both prompt and the network output, right? But you can't see the entire composition in ChatGPT because it's kind of an interface um, uh, designed to interact with GPT models, right? Okay, the simple thing is, so LLM is basically a next word predictor, and how you can interact with the LLM is basically by prompting. You just type something in, and the LLM will generate an output, right? So the problem is this: I mean, I hope you all have, I mean, have a, you all have had a chat with ChatGPT. So most of the time, right, when we have a, what do you call it, serious discussion, um, it fails to properly generate outputs, right? For a simple thing, of course, it can generate a proper, really nice outputs. But if we have a specific thing, for example, like, so here we are trying to learn how to do coding, right, or programming with LLMs. So that kind of a specific task is hard for most LLMs. The thing is, um, LLM can answer questions with regard to the data that it has been trained on very efficiently, right? So if I mean the context of the question is already in the training data, then definitely LLM can produce a really nice output. But the thing is, I mean, most of the time when we are asking a specific questions, right, the LLM either doesn't have the context to answer it, or it doesn't have the domain, like what do you call domain expertise, right? Then, but I mean, but anyway, the LLM generates an output, right? But then we can observe that the output is not relevant, and output is not informative. But still, LLM uh, generates output very confidently, right? So that's called hallucination. So I mean, usually, I mean, I usually have a, you know, have lengthy discussions with ChatGPT. Sometimes we forget, right? This is just a um, what do you call it? Just a model. But the thing is, and when the LLM fails to generate the relevant output, we have to understand that it's basically due to a couple of reasons. One thing is lack of domain specific knowledge. Second thing, hallucination, and not enough context. So then the thing is, even though LLMs are powerful, we have to use certain strategies to bias LLM's answer towards our goal, right? So generating relevant response, meaning you are making the LLM bias towards your domain or your question, right? So that's basically called prompt engineering. So if you think about a very simple question, so you can ask what is 10 plus 10, right? So the obvious answer is 20, but the question is, I mean, can't we get a separate or different answer for this one? Because the question is vague, right? The question is vague. There are multiple answers that you can think of for this given question. What is 10 plus 10? One answer is of course 20. That's the most probable answer. But still, we might need a separate answer. So then what we do is Hey guys, really sorry I got a power cut. Let me reshare the screen. Manit, will you be able to make me a host?
Uh, yes, sure.
Cool. Right, thanks. Okay, right. So yeah, we were talking about this question, and we have an obvious answer, and there can be different answers to this question as well, right? So what if we rephrase the question like this? So we say, okay, 1 plus 1 is an addition problem, 1 minus 1 is subtraction problem, likewise. Now then, what is 10 plus 10? So now the context change, so the answer should change. So now the most probable answer for this context is 10 plus 10 is an addition problem. So this is basically prompt engineering. So prompt engineering means simply means you are generating a response which is relevant to you, right? How do you generate a response from an LLM which is relevant to you? So that's basically called prompt engineering, right? And there are a bunch of different techniques that we can use to engineer the prompts, right? And we'll walk you through them, and in the latter part we'll discuss about how we can use these techniques for programming. Cool. First things first. So the most simplest and one of the most efficient techniques is introducing a persona, right? So I have like two scenarios, if you can see. So the first thing is I have asked GPT that what is explain what is an API in one sentence. So it has generated an answer which is okay. Now what I have done in the second prompt is I have introduced a persona, right? I have given a role to the LLM and I have said, okay, now you are a 3-year excited 3-year-old who is at a lot of sugar, right? Now explain what is an API in one sentence. Now see the differences of these two responses. So now, I mean, the LLM behaves like a 3-year-old, right? So if you observe the responses properly, the meaning is pretty much similar, but the way the response has been generated is totally different. So this is one of the most simplest but yet effective techniques that you can use to generate an answer, right? There's another example. Um, Pretend you are a Sherlock Holmes and deduce why the mysterious guest at the dinner party seemed anxious. So it behaves like Sherlock Holmes, likewise. So if you, for example, if you are um, using this persona to your like software engineering problems, you can specify, like, let's say you have a problem related to algorithms, certain algorithm. You can start with, okay, you are an expert in algorithmic design and evaluation, and answer to this question. Likewise. So introducing persona always works. So this is the first technique that you should follow. I mean, this keep this a keep this as a practice, and always add a persona, right? The answers or the responses are surprisingly good, actually. So the first technique is persona, and the second technique is instruction. So I mean, this is a very huge topic, how we can manage instructions in prompts. But simply, if you can compare these two prompts, right? So first prompt, tell me a story about cows. And second prompts, so you have certain instructions. Tell me a story about cows. It should be roughly 2000 words, one instruction. Long and appropriate for second graders, another instruction. Should be entertaining, third instruction, but with a moral message about the value of loyalty. Likewise, instead of just asking question or asking LLM to do certain things, you can provide instructions. So we'll talk about how we can provide instructions properly. But I mean, this kind of prompts works for ChatGPT, and but these prompts doesn't work um, well with the other LLMs, like if you are using Anthropic LLMs or let's say Mistral. So those for those LLMs we have a specific format. We'll get to that part later. But simply, if you're using simply GPT, make sure to add these kind of instructions and make the instructions very clear and short, right? Very clear and short. Okay, so now we have two techniques, adding a persona, and the second one is instructions. Yeah, simply LLMs can't read minds, you know. And yeah, the third technique is called context, right? So again, context meaning means adding more information or more background into your question. You can describe the background about, like, background information about your question. So I mean, so I have done two examples here. One thing is how to train a dog to bring particular ball in 3 sentences. So this question is very general question, and so it has generated the LLM has generated a response. But if you can see the second prompt, so I have explained the background stuff. So my dog is a 5-year-old German Shepherd. How to train my dog to bring a particular ball in 3 sentences. Make the training specific to the dog type and its age. So we are providing, so here we have instructions and we have more context, right? Now you can see the difference between the responses generated from the LLMs, right? So now we have 3: persona, instructions, and context. And when we add these concepts into the prompt, so we have to think about one more important thing. So that's called context window, right? So I hope you all have heard what is context window. So it's basically how much of information that you can put into a single prompt, right? So usually the context window is measured by tokens, right? So tokens, you can simply consider token as a couple of words, but different LLMs define tokens in different ways, right? So all of these informations are available on their documentation. So you can, one of the best practices that we have to follow is to go through the documentation of an LLM before using it. It could be GPT, it could be Anthropic, or anything, right? Because there are slight differences between each and every LLM, and so we have to, you know, consider them as well. So the thing is context window. So it's basically how much information that we can put into a single prompt, measured by um, um, tokens, right? um, so you have to be careful about the context window as well, right? For example, if you want to provide so much information into the LLM persona, and let's say you have huge amount of instructions as well, and then you better use an LLM with a huge context window, right? So each LLM has its own context window. So usually, I guess the LLM with the largest context window is Gemini, I guess, and Mistral models also have very huge context windows. So think about that as well. So if you exceeded the context window, then you will not get a response, right? And so here, this is another principle that we can follow in prompt engineering. We call 3C framework, right? So this framework has been created by combining the previous points. So basically, we have clarity, right? Providing clear intentions and context, background information, and constraints, right? So this is how we can basically provide this information, giving a role, that means the persona, right? And clarity and the context means you provide certain background information and you ask the question, right? And these are basically instructions, right? And here we have provided examples. We'll get to the examples part a bit later. So we have certain techniques called zero shot prompting, few shot prompting, and etc. But the key things are persona, instructions, and context, right? The thing is this, yeah. So I mean, even though we have mentioned several, you know, techniques, you don't need to use every technique in every prompt, right? It's up to you to decide which technique should be used for which use case. For example, if your question is obvious and it's very easy to answer, you don't have to specify a persona, right? And you can limit the context as well. So it depends on the use case actually. But since we are talking about how we can optimize prompts for engineering or software engineering or programming, probably you'll have to adapt all these techniques, right? So yeah, I mean, there is no single, what do you call it, single technique or single, yeah, magic sauce that we can use to write the best prompt. So it's an iterative process. So you can write an initial prompt by adapting these things, and you can check the response, and then change these parameters and stuff. Then you can decide what is the best prompt for you. And nowadays, I guess we have different prompt checking tools as well. So you can, I mean, compare a bunch of different tools at once with different LLMs. So better to use that kind of a tool. Um, but yeah, it's an iterative process. So if you are, I mean, my suggestion is, if you are going for a um, competition, and so I guess you usually get an idea about what kind of problem you get in the competition. In that case, you better create certain, you know, general prompts for different use cases, so that you can easily fine tune the prompts and use them in the competition. Yeah, but this is an iterative process. So the next thing is, I mean, given the 3C framework, the next important thing is to understand the LLMs, right? As I mentioned earlier, each and every LLM has its own way of communicating and working, so you have to properly understand the LLMs and their inner workings. For example, this is very uh, simple thing. For example, I mean, we talk about how we can uh, interact or integrate the instructions, right? But if you consider three different LLMs, right? So this is Mistral, this is Llama, and we have OpenAI. So the way these models are accepting instructions is different. For example, if you want to provide instructions, and you can for Mistral model, then you can use hash, and if you want to provide examples, then you have to use this notation. And for the meta, the thing is very different. We don't have specific tags. You can just provide the instruction in plain um, language, but they have certain constraints with the language, right? Explicit instructions are as using rules and restrictions. Avoid using jargons or technical terms that may confuse the model. Likewise, I mean, they don't have specific we call them tags, but they have specific, you know, techniques. For OpenAI also, we can use this hash or these codes like we use in doc strings to provide instructions and more context. Likewise, and if you are using anthropic models, it's a totally different one. We'll get to that part later, right? So the next important thing is understanding the the language of the LLM, right? Yeah, so these language stuff is called instruction tags. It's like LLMs wearing pants. So for Mistral models, so we have specific tags like this, right? If you go to Mistral documentation, they have this kind of thing. So if you want to start an instruction, you can use this tag inst, and you can provide the instruction here, and you can close the instruction tag, right? Like HTML. So we have, like, for Mistral we have huge amount of tags. So if you are planning to work with Mistral, then better to go to the documentation and read it properly, so that you can um, use these tags in the prompting efficiently. The thing is, like, I mean, let's say your context is very rich and your instructions are very clear and the user persona is also really nice, but if you didn't follow this specific language using instruction tags, you will not generate you will not get a, you know, proper answer. So the instruction tags matters. So this is how we do it in Llama 2, and same for other meta models as well. And here they have specific tags for system prompts as well. So we'll talk about system prompts if we have time, and you can do the instructions later, likewise. Right. So I'm not sure how these competition things, I mean, the prompting in competitions works. So if the organizers provide you you know, access to LLMs, you can use them. Otherwise, you have a bunch of different options to interact with LLMs. One thing is each LLM provider has its own, hosted API services. GPT, Anthropic, Mistral, pretty much all the LLM providers. And most of the LLMs are available in cloud. In AWS, we have a service called Bedrock, AWS Bedrock, and in AWS Bedrock we have most of the LLMs available, including Gemini and Llama 3.1. You can use Bedrock, and if you want, you can host your own model. You can just download the weights and create a Docker container, and you can deploy the model there as well. Other than that, you have different other services that you can use called Anyscale, Together AI, and Quora. So these providers have certain free tiers. You can just note these things down and just do Google search and try to get a free tier, and so that you can play around with a bunch of different LLMs. Because the thing is, I mean, the LLM that we use mostly is GPT, but when it comes to competitive programming, um, it's not that, not that good in competitive programming. So we'll have to look into the other options. Yeah. So let's say um, you have given proper persona, proper instructions, proper context, and you have used proper instruction tags. Now everything is done, and yet you are not getting the responses that you want. I'm not talking about programming answers, but let's assume the general context, right? Then what you can do to improve the responses is to change the sampling techniques, right? With each and every LLM, we have certain parameters that we can fine tune, right? So if you think about a typical machine learning model, we have certain parameters that we can change and optimize. We call them hyperparameters, right? But given the nature of the LLM, we can't uh, use hyperparameters. But the LLM providers have given certain parameters to change. They are called inference parameters. So if you have heard temperature and top K, top P, those things are called uh, inference parameters. And inference parameters also play a major role in generating a proper response. Actually, I'm not that sure. Let me check. Not hearing anything, Manit, but let's see. So the first thing is we have certain techniques called sampling techniques, right? So usually the LLM output is generated by greedy sampling, right? And so greedy sampling means, so whenever LLM generates a response, so if you are familiar with the transform architecture, right, the response is generated as a probability distribution, and at the end what we are getting as response is the most probable option, right? So always getting the most probable option, or most probable answer is called greedy sampling, right? So the default sampling techniques available in the most of the LLMs is called greedy sampling, right? The drawback is this. So greedy sampling always results in the same distribution. So regardless of your prompt or anything, you are getting the same response, right? Then if you let's assume you have fine-tuned all the 3C framework, all the instructions and everything, still you are getting the same response that you don't want. What you can do is change greedy sampling and use random sampling. So random sampling, what it does is, so we can instead of getting the most probable answer, the answer with the most or the highest probability, what you can do is you can pick the top n number of answers which has the highest probabilities, and then pick a random answer out of that sample, right? So if you can hear, now this is temperature, there you go, right? So let's say here, so you have a couple of answers with their probabilities, right? And usually if you are using greedy sample, we should get 0.2 because that's the most probable answer, right? But if we change the greedy sampling into random sampling, what you can do is you can specify, okay, let's pick the top 3. So here the n is 3, top 3 answers based on the probabilities, and then pick a random sample out of it. So what are the most probable answers? 3 answers: cake, donut and banana. And then what we are going to do is the LLM is going to pick an option randomly. So that means we have given the space to vary, right, the answer. So that's called random sampling. So you have two parameters that you can use with random sampling: top n and top p, right? So top n means you control, okay, I want top this number of samples and then pick a random observation out of it. And top p means you can specify a probability. Okay, you calculate the top probabilities, cumulative probabilities, and consider all the probabilities less than given my threshold value. For example, if we provide top p as 0.33, that means you are getting the most probable one and the next one. So the total of these two probabilities is 0.3. So it's the highest value less than our p value, and then the LLM will pick a random observation from these two. So that's how you increase the randomness of the answers. So this is one of the least used technique by prompt engineers, but still very effective. If you are getting the same response again and again and again with all these parameters, all these techniques implemented, then you have to shift from top random greedy sampling to random sampling, right? And these I don't think these parameters are available in the interface ChatGPT, but you can use these things programmatically, right? And all right, and one thing to notice, you shouldn't increase I mean the the top N and top P drastically, because then you are providing too much flexibility to your LLM, so it will generate answers here and there. If you want to create a story or anything, then this is just fine, but in specific tasks, you should use these parameters with a uh, with a you have to be careful, right? And the next thing is temperature. I hope you all know the temperature. So temperature, what it does is it manipulates the output distribution of the LLM. So instead of, so see, so the if the temperature is low, you have the skewed distribution. So it's very easy to um, pick the answer. So if you want to get very specific answer, then you have to reduce the temperature. And if your answer can can be creative, if you want your answer to be creative, then you can increase the temperature, right? Um, the default value, I guess, for GPT is 0.3. But if you are doing a specific task, you can just make it 0. Right. So we have discussed bunch of different stuff. So if we revising them, we have user persona, instructions, adding context, using the instruction tags specified to LLMs, and then you can manipulate the sampling techniques, greedy sampling, random sampling. Under random sampling, you have top N and top K, top N and top P, and then you can control the temperature, right? So now we'll talk a bit about another concept which is very useful if your problem is complex, right? So all of these prompts that we saw here, they are called zero-shot prompting. We are not providing examples, right? We are just asking the questions. So that's called zero-shot prompting, right? So zero-shot prompting is basically good for simple tasks. Like, if your task is, or the question is obvious, then you don't need to specify examples. So it becomes zero-shot prompting. Likewise, so let's say you have a text, right, and you want to extract these certain informations into a JSON output, right? So the task is simple, so you don't have to specify any examples. So extract date, addresses, and telephone numbers from following text and provide a JSON containing the entities. Just provide the JSON, nothing else. So it will nicely generate an output. So for this kind of task, you don't need examples. So you can use zero-shot prompting. So few-shot prompting is basically, you can, if your task is a bit complex, you can provide a couple of examples. You can provide either one example or you can provide multiple examples. Usually the number of examples vary from 1 to 5, right? If you have to provide uh, more than 5 examples, then your problem cannot be resolved with just this kind of prompting. Either you have to use an advanced techniques like chain of thoughts, tree of thoughts, we'll get to that part, or you have to use another techniques called, either you have to fine tune the LLM, either you have to use a RAG pipeline kind of thing, right? The limitation is 5. So feature prompting is used for, you know, moderately complex tasks, right? See, they generate a rhyming couplet about a tree. Input cat, output the curious. So here, this is the question, and these are the examples. So this is the first example. Input cat, output, we have a pattern, right? And we have the second example, input and the expected output. And this is our input value, and we are expecting the output. So it generates the outputs. So this is called few shot prompting, right? Yeah, so this is also a few shot prompting that you can use. So let's assume you want to generate a code which follows a specific format or a standard or something, right? Then what you can do is you can simply provide instruction or examples. So if you can see here, I have provided the examples, right, on the output structure that I need. So the LLM will generate a code which follows this output formats. Likewise, generating providing examples is really useful. Another example. So yeah, likewise, see here I have provided an example. Okay, so now we have discussed bunch of different techniques: adding a persona, instructions, context, greedy sampling, random sampling, temperature scaling, and then you have few shot prompting, zero shot prompting. And now if your task is very complex, which involves reasoning, right, you can use advanced techniques like chain of thoughts. So the chain of thoughts is very useful in competitive programming, right? Because in competitive programming, you are trying to solve a question, right, which involves thinking or reasoning. Now in that case, you can use chain of thoughts. So chain of thoughts means you provide the question with a way of thinking, right? So you provide a question and you provide an example, but the example involves certain way of thinking, right? You can see here. So we have the standard prompting here. Roger has 5 tennis balls, buys 2 more cans. Each can has 3 tennis balls. How many tennis balls he does have now, right? The answer is, I mean, we have provided the answer. So this is the example, right? Example question, example answer. And we have another question, right? The cafeteria had 23 apples, blah, blah, blah. And here the output is incorrect. Even though we provide an example, the output is incorrect. Then what we can do is we can move to chain of thoughts prompting. So chain of thought prompting means you have the question, and in the example you can provide how you get to the answer. Roger started with 5 balls. 2 cans of 3 tennis balls each is 6 tennis balls. So 5 plus 6 is 11. The answer is 11. So you explain how to get to the answer, right? And then the LLM provides an answer. So this is an advanced techniques. This is heavily used in LLM agents. So if you are building an agents, you can provide this chain of thoughts prompting as a reasoning. framework. This is very important in competitive programming as well. Usually when we are given a problem in hackathons or anything, so you are provided with several hints or steps to get to the answer, right? So you can incorporate those things in this chain of thoughts prompting, and then you can easily get the answer, right? That's fun advanced techniques. I mean, I can't explain like the entire thing about chain of thoughts here, but I'll send you some resources. So another advanced technique which is advanced than chain of thought is tree of thoughts. So you have different possibilities, so you have different steps, and in each step you have different possibilities. You can ask LLM to evaluate each and every step and find a route to get to the answer. That's called tree of thoughts, right? So this tree of thoughts, thought promptings are, I mean, this is way too advanced to use in a use in a hackathon to program. But if you are building agents, if your hackathon is to build a LLM agent, then tree of thought prompting would be a nice way. And we have another framework. So these chain of thoughts, tree of thoughts, and we have another one called React. These things are called reasoning frameworks, way different ways of thinking, right? Uh, this is not very useful for just general prompting, but if you are using, again, if you are building LLM agents, then you can integrate um, React prompting, reasoning and acting. That means you can do certain, I mean, you can ask LLM to do certain things, and then based on the results that the LLM gets, you can ask it to reason out. Okay, first do that, get the answer, and then reason out. And based on the reason, based on the you know based on your conclusion, do another step, something like that. Cool. So we have discussed so much information. The time is already up, but let me quickly walk you through the remainings. So the common errors: vague or ambiguous prompts, the obvious, lack of contextual information, sufficient examples, but please make sure that you don't provide more than 5 examples. If your problem is not resolved with 5 examples, that means you should have uh, you should follow a different approach, and you have to test the prompts as well, right? So yeah, persona, this is instruction tags, yeah, you can specify do's and don'ts. This is very important in competitive programming. You are given set of what do you call constraints. Provide those constraints specifically under instructions, right? Okay, so how as developers, how we can use prompt engineering is basically, I don't um, I don't recommend to use prompt engineering to deal with to deal with engineering task directly, because engineering, I mean, whether you are doing a hackathon or you are building something or developing something, first you should think about the problem, and you should break down the problem into manageable subtasks, and then you can use LLMs to get the answer, or like, or else I would say you can ask LLM to do or code specific things, but I don't recommend you asking LLM to do thinking for you, right? At least try to provide a rough guidelines or rough outline of thinking instead of just providing the problem. So you can use prompting as developer or an engineer to get refactor suggestions, you know, if you want to improve your code. And let's say you have a code from one language and you want to convert it to another language. For example, you have code or function in JavaScript and you want to get the Python version of it. For that kind of thing, just use the LLM, don't code. um, and you can use LLMs to write test cases, very useful. And as developers, um, I mean, in most of the hackathons also, you have to write unit test and integration test. So I recommend you to use LLMs to write those tests and the documentation. Yeah, of course, learn new technologies, but that's not relevant for competitive programming. And for debugging, right? Personal suggestion: don't use ChatGPT or GPT for debugging. It will make things worse. Yeah, if you are using prompting for programming, uh, make sure to address these things, right? Clearly provide the requirement in clear words, specify the instructions and the constraints properly under the instructions. And I mean, in most of the cases, like regardless of the competitions or real coding or development, you will get to address the edge cases, right? Mention edge cases also in the instructions, right? Those things are very important. So if you're writing a prompt for coding, try to address these points. Yeah, again, the use cases. Test case generation is one of the most famous use cases for in engineering. And code optimization. Okay, this is a pro tip from me. If you are using LLMs for coding, don't use a single LLM, right? So use two LLMs side by side. So you can generate a response, um, give the question and get an answer code from from one LLM, and give that code to another LLM and ask it to optimize the code, right? So that way you can generate the most efficient answer, because in the competitions, you can't just code and submit, right? You have to consider the time complexity, and you have to make things optimize and stuff as well. So don't use a single LLM, use two LLMs. That's how I do it. I usually use Anthropic's Opus for coding, and then I get the answer, and I use Gemini to optimize it, right? That way you can get the best possible answer. And of course, debugging is common use case. Yeah, finally, best LLMs for programming is, so these are not in order. My best LLM for programming is Anthropic Claude Opus. So this is the largest model in Anthropic family, and Anthropic has a couple of other models, like we have Claude 3 Sonnet, Claude 3.5 Sonnet, and Haiku. So those models are available in Anthropic, right? But the Opus model is very good, very nice for complex reasoning and code generation. So my number one recommendation is that it is available in AWS Bedrock, and you can have the direct, I mean, Anthropic's API as well. And the second option is Gemini, very good for reasoning and very good for optimization, right? So what I usually do is I generate the code, but again remember that you have to do the reasoning stuff, right? So I use the Opus, generate the output, and then give it to Gemini and ask it to optimize the code. And Llama 3 and 3.1 is also nice. Um, and I highly doubt about GPT 3.5 and GPT 4. So there are several reasons for failing to generate proper codes. Um, but I mean, I don't recommend you to use GPT-4 or GPT 3.5 for complex reasoning. If you want to do just generators, just regular code, that's perfectly fine. But if you want to, let's say you have to do an algorithmic reasoning, algorithmic optimization, those kind of things, never use GPT-4. It's just a waste of time, right? And if you can, try to use two LLMs side by side, so that you can get the best out of all the LLMs. So I guess that's pretty much it from my end. Not sure whether the session is informative enough, but yeah, I got only 1 hour, and yeah, that's pretty much it. And if you have questions, we can talk. Thank you, guys.
Thank you so much, Mr. Gihan Liyanage, for that insightful and engaging session. Your willingness to share your knowledge and expertise is truly appreciated. I'm sure everyone has gained a wealth of knowledge. We now have time for the Q&A session. If anyone has any question, please feel free to unmute yourself or type your questions in the chat box. This is your chance to ask anything or share your thoughts, and we are here to help.
I guess we got one question. How can we start building AI models by ourselves? I mean, are you talking about how we can build an LLM by ourselves, or the question is not clear? I mean, yeah, okay. Building an LLM for ourselves is nearly impossible, I would say, for us, because I mean, you have, I mean, basically two major reasons. One thing is you have to have huge amount of data, right? So huge amount of data means huge amount of computation power, right? So you have to build proper, data ingestion pipeline, and like huge amount of effort and cost you have to put into this process if you want to build your own LLM. Um, but I mean, in AI community Sri Lanka, now we are trying to build a Sinhala and Tamil LLM for uh, Tamil LLM by ourselves. So if you want to contribute to that, you can just go to LinkedIn or Facebook and just search AI community Sri Lanka and talk to one of the organizers. So at the moment we are actually building a single and Tamil LLM. It's a collaborative effort because we can't, I mean, a single person can't do. So we um, um, yeah, we are working as a team and trying to build an LLM. But for a single person, I don't think we can. Future of LLMs. Okay, I mean, just I'll give you a quick answer. Um, um, I think, I mean, now the LLM has become, or the future of LLM has become an infrastructure problem, right? I mean, we can improve LLMs by adding more parameters. That means the model becomes huge, and we need infrastructure to host it and train it, right? But I think future of LLM would be, I mean, in the future we might use a different LLM architectures. Like now we are using the attention mechanism, but there are certain limitations in attention mechanism which prevent us from, you know, getting to the next level. Now if you can, now the researchers are working on building more efficient language models using state space architectures. If you have heard Mamba, there's a model called Mamba. You can just Google search and read about it. So people are slowly moving towards different architectures. Yeah, we will get to the AGI, but not pretty soon. So let's say another question. Let's say for a specific task like generating timetables, can we build AI models for that? For this kind of task, we don't need to build an LLM by ourselves. You can use an existing LLM, right? And then you can build a system around it. Maybe um, you can use agents, or you can use a RAG pipeline, right? Or you can combine both and create an agentic RAG pipeline. Likewise, you can build LLM based applications. So my recommendation is to look into Llama Index and LangChain. So those two frameworks provide capabilities to build these kind of applications. Okay.
Any questions? So there's another question. So you're muted.
Really sorry. I mean, I mean, there are different perspectives to that question. I mean, if you can be specific, then I can answer. I mean, yeah, can be, that would be a separate topic, I would say. Any other questions? um, yeah, ethical concerns, all these stuff. I mean, it's actually a separate topic. So that's one of the like emerging areas of AI called like on like how to build ethical AI systems, right? Because so AI means we are replicating us humans, right? We have certain flaws, right? For example, if you think about the previous like the early stages of GPT, so the responses were really racist, right? So and on the that means we have to think about how we manage the training data, and um, as organizations we have to think about how we can manage our like organizational data, privacy data with LLMs. For example, we have certain practices for that. For example, if you are working on a sensitive data, you don't fine tune LLMs, right? For those kind of things, you have RAG or something like that. If you want to fine tune, and then you have to host the LLM in your local infrastructure, that kind of thing. But ethical concerns is a really big topic, but I mean, the responsibility comes to us to properly use LLMs, right? So we have another question. Most of the guys ask me about there's a roadmap to learn ML. Yeah, if you want, I can give you guys a roadmap, or you have, we have bunch of different roadmaps available in the online, like in different websites, but I highly recommend you guys to follow deep learning AI. So in Coursera, we have something called Deep Learning AI. It's an organization formed by two like pioneers in deep learning or AI, um, and you can find different roadmaps, different learning paths, specializations to get started with ML. That's for sure. I think that's the best resource that I know. Yeah.
Thank you, sir, and thank you everyone who asked questions. And I hope you all got the clear answers. So, on behalf of everyone here, I would like to express our sincere gratitude to Mr. Gihan Liyanage for sharing such valuable insights with us today. As a gesture of our appreciation, we are pleased to present you with a digital token of appreciation. So, please accept this digital token of appreciation.
Thanks so much, guys.
To conclude today's session, I'd like to invite Ms. Amalsha Vitanagi, the event secretary of IEEE Extreme 18.2, to extend the vote of thanks. Over to you, Amalsha.
Good evening, everyone. Distinguished guest speaker and dear participants. On behalf of the IEEE Student Branch of General Sir John Kuthalawala Defence University, it is my pleasure to extend a heartfelt vote of thanks to all who contributed to the success of today's workshop. First and foremost, I would like to express sincere gratitude to our guest speaker of today's session, Mr. Gihan Liyanage, for sharing his valuable insights. His session on prompt engineering for competitive programming has provided us with practical knowledge and techniques that will surely benefit participants as they prepare for the upcoming mini hackathon Byte Weeks and the 24-hour global coding competition IEEE Extreme 18.0. To all the students who joined us today, thank you for your active participation and engagement. Your enthusiasm is what made day one of this workshop series impactful. And I hope today's session has been both informative and inspiring for your journey in competitive programming. I would like also to acknowledge the organizing committee of IEEE Extreme 18.0 for their hard work and dedication in organizing this series. Without your commitment, today's event would not have been possible. Looking ahead, we are also excited to announce our next session on September 28th, where we will focus on data structures and algorithms. And we look forward to seeing you all there. Once again, thank you all for your time and contribution, and have a great evening. Thank you. I'm Amalja Vitanage, Event Secretary, IEEE Extreme 18.0, IEEE Student Branch, General Sir John Kottawa Defense University. Thank you.
Thank you, Amasha, for that wonderful vote of thanks. Before we wrap up, we'd love to capture this special moment with everyone. Could I kindly ask you all to turn on your cameras for a quick group photo? Also, please remember to change your background to the virtual one we have provided. Okay, let's get ready. Let's go. On my count, 3, 2, 1. Say cheese. Thank you so much. Before we wrap up, I'm excited to let you know that we have another amazing workshop coming up on September 28th, where you will get to learn more about data structures and algorithms for competitive programming. We encourage you all to participate in that session as well. Additionally, we are hosting a mini hackathon by Blitz to help you gain a better understanding and practice more for the upcoming IEEE Extreme 18.0. So this concludes our workshop for today. We hope to see you in future sessions. Thank you and have a great evening.
See you guys.